Here we are at example 10 from our 5.2 set of notes. We're asked, instead of saying the right side rises and like the left side, falls, things like that, in math we actually say things like as x goes towards positive infinity, f of x goes towards positive infinity. And that pretty much just means that and so pretty much this is actually just a formal way of saying as you go to the right for x, what are the y's doing? Or as you go to the left for x, what are the y's doing? So on a standard xy coordinate plane, this is our x-axis, this is our y-axis. And in the past we've talked about y is the exact same thing as saying f of x. It's the exact same thing. And this really, f of x describes the end behavior. So maybe it's going towards positive infinity or negative infinity. Every single time, for any polynomial, it doesn't matter if it's in even or odd degree, meaning like u or s, doesn't matter if its leading coefficient's positive or negative, does not matter. Every single time, in terms of talking about end behaviors, you're always going to start off with x, as x is going towards positive infinity, f of x is doing what? And then as x is going towards negative infinity, f of x is doing what? So that's really what we're answering here. So in other words, what that means is as x goes outwards towards infinity, and you can keep going. You can always just keep going further. Is it going up towards positive infinity or is it going down towards negative infinity? Likewise, as x goes towards negative infinity, in other words, as the x values are decreasing or you're going this way for x, is it going upwards? Is it rising towards positive infinity? Or is it falling down towards negative infinity? But every single time, doesn't matter any scenario, you are always starting off with this. And again, this is really just the formal way of saying what we were before. Right side, left side, is it rising, falling, that kind of thing. Okay. So for example 10, we kind of just want to say what's pretty much happening here. Well, according to this polynomial, we said that it was an s doing something like this. And so we see that the right side's going towards, if it's rising, it's going towards positive infinity. Whereas the left side, we see it was falling down toward negative infinity. And the reason why we use infinities is because you can literally keep going. These arrows are going to extend forever and ever and ever. So that's why we use the infinity symbols. So for the second one, we'll switch up the colors. Again, always, every single time starting off with, as x goes to infinity, f of x is doing what? Right now, no clue. As x goes towards negative infinity, f of x is doing what? Again, no idea. But just referencing back to the right side, what's happening? It's falling. Well, then it's going to be going, f of x is going to be going down toward negative infinity. Whereas x is going to the left side, or if you're going towards negative infinity for x's, we see that it is rising. And that is rising towards positive infinity. For the last one, as x, again, always the start, same start. As x goes to infinity, f of x is doing what? Or as x is going towards negative infinity, f of x is doing what? So as x goes towards positive infinity, it's falling down toward negative infinity. As x goes outwards towards negative infinity, according to this one, we said that it was falling down toward negative infinity. So again, the infinities are just a really formal way. This entire setup is just a formal way of saying the end behaviors. don't get too intimidated just because you're dealing with infinities. It's literally just the same exact thing as saying it's either rising, which would be then it's going upwards to infinity, or if it's falling, it's just down toward negative infinity. So don't let this intimidate you. Like I said, in calculus, you're going to see this right from the start. All right. But again, that is example 10 from our 5.2 set of notes.